Hey everyone, welcome back. In this video, we're going to talk a bit more about linear functions. Earlier, we talked about the slope formula and slope-intercept form and how we can use those to help us find the equation of a line. In this video, I want to talk about another form that we will often use called point-slope form. So if we want to use our slope-intercept form to help us find the equation of our line, we really need these two pieces of information, m and b. M represents the slope of our line, which we can find if we know 2 points our line goes through, and b represents what we call the y-intercept of our line, which is that 1 point where our line crosses the y-axis. And so in problems where we're trying to find the slope-intercept form of our line, and we know the slope and a couple points our line goes through, what we often have to end up doing is plugging in the value for our slope as well as the information for one of those points, that x and y value, and then solving for b. All right, so now let's go ahead and look at an example of using point-slope form to help us find our equation of a line. And at the end of the example, we'll see that it's going to give us the same line even if we had tried to use slope-intercept form from the start. All right, so in our example, we are asked to find the equation of the line that goes through the two given points. The first point is -1, 5, and the second point is 2, -1. So we can do this problem totally algebraically. There is no need to draw a picture, but it's always nice and can help us check our work, make sure we are on the right track. So let's go ahead and sketch our line really quickly, which we can do since we know 2 points our line goes through. So the first point is -1, 5. That'll put us somewhere up here in the second quadrant. And our second point is 2, -1. That'll put us somewhere down there in the fourth quadrant. Now if we draw the straight line connecting those 2 points, which is the hardest part for me usually, we will get the graph of our line. And how this graph can help us check our work as well, we can observe from the graph we sketched that our line is decreasing, so it should have a negative slope. And also it crosses the y-axis up here above the x-axis, meaning that we should have a positive y-intercept. So like I mentioned earlier, we'll go ahead and find the equation of this line using both of our forms, our slope-intercept form as well as our point-slope form. And no matter which form we decide to use here, we really only need to use one. They both require us to get started by finding the slope using our slope formula. All right, so another way to remember the slope formula is the change in y over the change in x, or the rise over run. So if we think of this as our second point, 2, -1 as our second point, and -1, 5 as our first point, then this will be x2, y2, and these values will be x1, y1. So our slope formula should look like -1 minus 5, right? That's y2 minus y1 divided by 2 minus -1, that's x2 minus x1. And we got to be careful here. Remember, when you subtract a negative, it turns into addition. So if we simplify the numerator, -1 minus 5 is -6. 2 minus -1 in the denominator will simplify to positive 3. And -6 over 3 is -2. So now we know the slope of our line is m equals -2. And so now that we know the slope, we can find the equation of our line. Let's go ahead and first do it using point-slope form. So if we want to use point-slope form, we need to know the slope of our line, m. That's -2. We know that already from our previous work. And then we need one other point that our line goes through. And it doesn't matter which point we use here. In fact, let's go ahead and do it for both. So if we use the first point, -1, 5, as x1 and y1, then our point-slope form equation of our line should look like y minus y1, so it'll be y minus 5, is equal to our slope value m, or -2, multiplied by our variable x, minus the x value corresponding to that point we are using. That x value is -1, and remember, x minus -1 is going to turn into x plus 1. So we have the equation for our line expressed in point-slope form. Y minus 5 is equal to -2 times the quantity x plus 1. I mentioned a moment ago that it shouldn't matter which point we use as x1, y1. We just need one point that our line goes through and the slope, and we'll get the same equation every single time. And so just to verify that, let's go ahead and do it again with our second point. So now our y value is -1. So the left-hand side of our point-slope form equation is going to look like y minus -1. But those two negatives will turn into a positive, giving us y plus 1. Then we have our same slope of -2. That's our m value. And we have to multiply that by the quantity in parentheses, x minus our x1 value, which is now 2. So it'll look like x minus 2 inside of those parentheses. So we have these two equations here that we found using our point-slope form, and some of the quantities involved, the numbers involved are different, so that may, at first glance, make it look like we have two different equations, but these two equations are exactly the same and are describing the exact same line. One way to verify that is to actually simplify both of our point-slope form equations and put them into our slope-intercept form, which is the form we use most of the time and almost always want to write our linear functions in slope-intercept form. So as a quick little exercise, let's go ahead and convert all of our point-slope form equations to slope-intercept form equations. And in doing this, we'll see that they actually are the exact same equation. So how do we go from point-slope form to slope-intercept form? Well, we really just have to solve for y, and then on the other side of our equation, combine like terms. All right, so let's see. If we want to solve our first equation for y, we're going to have to add 5 to each side. So let's put that up here as our little placeholder. We have to expand this quantity inside of parentheses. So that'll give us negative 2 times x. And then we have negative 2 times 1. So we get that constant term of negative 2 that combines with our other constant term of positive 5. And negative 2 plus 5 is positive 3. So just by solving for y and combining like terms for that first equation in our point-slope form, we get this equation in slope-intercept form, y equals negative 2x plus 3. And unless I made a mistake, that's exactly what we should get for our second point-slope form equation as well. All right, so let's go ahead and do that. This time, to get y by itself, we're going to have to subtract 1 from each side. If we first expand that right-hand side, we get negative 2x. Then we have negative 2 times another negative 2. That gives us a positive 4. We have to combine that positive 4 with that negative 1 that we subtracted from both sides. So positive 4 minus 1 is, what do you know? Positive 3. So like I said, it really doesn't matter what point you use when using point-slope form. That's one of the advantages of this form. If you take your point-slope form equation and move things around, you'll always be able to turn them into that standard slope-intercept form. So really quickly, just for fun and as a reminder, what if we wanted to find our equation not using point-slope form at all, but using that original slope-intercept form? Well, we start with what we know. Our slope is negative 2. So our equation is going to look like y is equal to negative 2x plus b, where b is that y-intercept. That is the y value corresponding to when x is equal to 0. That's not one of the points that we know or were given. So in order to find that b value, we have to plug in either of these points and solve for b. Let's go ahead and use that first point, negative 1, 5. So if we plug in x equals negative 1 and y equals 5, our equation becomes 5 is equal to negative 2 times negative 1 plus b. But negative 2 times negative 1 is positive 2. And so what do we have to add to 2 to get 5? That's our b value. And that's going to be 3. But now if we plug that b value back in, we get, once again, y is equal to negative 2x plus 3. That's the only equation we're really going to find for this line, because there is only one equation for this line.